when we are talking about slopes, we usually talk about two parallel lines and two perpendicular lines and properties of the slopes of two parallel lines and perpendicular lines. We know that for two parallel lines, slopes are always equal, because see, uh, parallel lines itself means they are having same inclination with respect to horizontal. That means the slopes are always equal. Now, before going into this topic, let me discuss about what is slope here. See, slope is nothing but the angle of inclination. To be more precise, it is nothing but tangent of the angle made by the 2 points or line joining with the 2 points with respect to horizontal. Slope is defined as the tangent of the angle made by the line with respect to horizontal. Now, for example, let us take 2 points in Cartesian plane. Let us take 2 points in Cartesian plane. Let the first point be x1 y1 and another point be x2 y2. Let the first point be x1 y1 and another point be x2 y2. See, as I discussed the definition of from the definition of slope, slope is defined as the tangent of the angle made by the line with respect to horizontal. Now, if we join a line with these 2 points, the angle made by this line with respect to horizontal is known as slope. Okay, so slope is nothing but the angle of inclination of a line. When we are talking about the slope of a line, it is nothing but the angle of inclination of a line, or to be more precise, it is tangent of the angle, so it is given by tan theta. Now, in coordinate geometry, particularly in Cartesian plane, we have the separate formula to find slope if 2 points are given. So slope is given by m is equal to y2 minus y1 by x2 minus x1. But wait, how this formula came and what is meant by slope in general language? See, I think we might have heard this word a lot of times before coming here or before discussing about this topic. Slope is nothing but the steepness of a line. So when we are inclining or when we are climbing a road in uphill, or when we are accelerating upwards, or when we are decelerating downwards, we need to encounter a road which is making an angle with respect to horizontal. That means it may be a somewhat steep upwards or steep downwards. It's nothing but, see, the angle made by this the real line, or to be more precise, when we are talking about these roads or when we're talking about these tracks, they are not always horizontal. They might be somewhat upwards or they might be somewhat downwards. So if a line is like this, sometimes it may be like this, sometimes it may be like this, sometimes it may be like this. See, the steepness of this line with respect to horizontal. Now if we talk about this line, the first line, it is having a slope which is not that much. When we are talking about the second line, it is having much slope, and when we are talking about third line, it is much steeper. So more is the steeper, more is the slope. More is the steeper, more is the angle. That means if angle is more, the steepness will be more. So that's why slope is given by tan theta, and we know that tan theta is an increasing graph. Now how does this formula came? Now, as we discussed, slope is given by tan theta, and we know that from ratio of trigonometry, tan theta is defined as opposite side by adjacent side. Now in this triangle, opposite is this thing. Let us name it as some OAB. So opposite is AB by adjacent is OA. Now AB is given by y2 minus y1. How? See, when we are writing coordinates x2 comma y2, it means that the point B is at a height of y2 from the x-axis. Let me show here. This is y2, and the x coordinate of the point B is x2. That means it is at a distance of x2 from the y axis. Now, similarly, the point O is having coordinates x1, y1. That means it is at a height of y1 from x-axis, and it is at a distance of x1 from y-axis. Now, since I only require this AB, this part only AB, so I mean I'm not required to find this entire distance. I only require this AB. Now, how to find AB? So AB is nothing but total y2 minus this y1. So y2 minus y1 by OA is x2 minus x1, because OA, the distance of point A from y-axis is x2 and the distance of point O from the y-axis is x1, and I need only OA, so it is given by x2 minus x1. So therefore tan theta is equal to y2 minus y1 by x2 minus x1. Now, coming to the topic which we have discussed earlier, two parallel lines. But suppose if we are having two parallel lines, let us say these two are parallel lines, the slopes of two parallel lines are always equal. How? The slopes of two parallel lines are always equal. For example, let us consider two parallel lines. Let it be one line. And slope is always measured with respect to horizontal, so it will be theta. So therefore the line 1, slope of line 1 will be m1 is equal to tan theta. Now let us draw another line which is parallel to line 1. Let it be like this, L2. Okay, so let us draw another line which is parallel to L1. Now how to find the slope of this line? Now, since these two are parallel, if we extend this line to meet this horizontal, since these two lines are parallel, so the angle made by the line 1 is nothing but angle made by the line 2, so this will also be theta. So therefore m2 is also equal to tan theta. So therefore both m1 and m2 are equal for two parallel lines. Now coming to perpendicular lines. Now what does this indicate? Perpendicular. Perpendicular means if two lines are inclined together at a if two lines are having an angle of 90 degrees between them, if two lines are making right angle with respect to each other, then they can be said to be perpendicular. For example, let us take one line, let it be line 1, and let us take one more line, let it be line 2, and they are mutually making an angle 90 degrees with respect to each other. That means they are perpendicular. Now how to find the slope of each line? Now the slope of first line is given by theta, so therefore for L1 the slope of first line m1 is given by tan theta, and for L2, as I discussed, for any line slope is always measured with respect to horizontal. Slope is nothing but it is defined as the angle made by the line with respect to horizontal. So here line L2 is making an angle of 90 plus theta with respect to horizontal, so it is given by tan 90 plus theta. because from the definition of slope is nothing but the angle made by the line with respect to horizontal surface. So here the line L1 is making an angle theta with respect to horizontal, and here the line L2 is making an angle of 90 plus theta with respect to horizontal. So m1 is tan theta and m2 is tan 90 plus theta. Now if we do the product of m1 into m2, m1 and m2, so m1 is given by tan theta and m2 is given by tan 90 plus theta, and we know that tan 90 plus theta is negative cot theta. Since because whenever 90 degrees is there or odd multiples of 90s are there, we need to apply the complementary of tan theta, so it will be cot theta, and 90 plus theta is in second quadrant, that's why it will be negative. So tan theta into negative cot theta can be written as minus 1 by tan theta. So here tan theta gets cancelled, and the answer is minus 1, and this is how we got the property m1 into m2 is equal to minus 1. So for two perpendicular lines, when we talk about the properties of slopes, the product of slopes is always equal to minus 1, whereas for parallel lines, the slopes are always equal. So it's very important topic, and you need to be thorough with this concept rather than directly remembering m1 into m2 is equal to minus 1.